question 8. So for part A, calculate the number of primroses at the start of the study. Well, that's when t equals 0. So 1 to the power of e to the power of 0 is 1, and similarly in the denominator e to the power of 0 is 1. So we've actually got 800 times 1 over 3 plus 1 plus 3 times 1. So 800 over 1 plus 3, 800 over 4, which is 200. Now for part B, we've been told to set P at 250. So substituting in 250 equals our right hand side. So choose to multiply through by our denominator, then multiply out the bracket gives us this. I've taken 750 e to the power of 0.1t away from both sides, because that giving us this, so 250 equals 50 lots of e to the power of 0.1t. Divide through by 50 gives us 5 equals e to the 0.1t. Ln both sides, we get ln 5 equals 0.1t. Multiply by 10, we get t equaling 10 ln 5 as our exact answer for t. Now for part C, we've been asked to find the exact value of dB dt when t is 10. So P is where we are dividing, so to differentiate this we need to use the quotient rule. So dP dt equals v du dt minus u dv dt all over v squared. U is the numerator, 800 e to the 0.1t, and v is the denominator, 1 plus 3 e 0.1 to the 0.1t. Differentiated the numerator, u differentiated the denominator. Remember, when you differentiate e, you remain with the same e to the 0.1t, but we've got to multiply by the differential of that part there, so by the 0.1, hence 800 becoming 80 and 3 becoming 0.3, multiplying by 0.1 on both occasions. Substituting in and at the same time choosing to let t equals 10, which is very convenient because on every single occasion they're becoming e to the 1, so e, we get this, and that simplifies down to 80e all over 1 plus 3e all squared. Now for part D, explain why the population of primroses can never be 270. Now this takes a bit of thought. You've got to spot that the best way to really see where P maximizes. At the moment we've got two terms which are being multiplied by e to the 0.1t, which makes it very difficult to gather our thoughts. So in a way we want to eliminate that. If we choose to divide through each term by e to the 0.1t, then only the 1 is now a function of t. So by dividing through by e to the 0.1t, we get 800 all over e to the minus 0.1t plus 3. So we can now focus upon this value here, and as t gets bigger and bigger and bigger, this is approaching 0 all the time. So our maximum p is 800 over 3, which is 266 2/3, not quite reaching not quite reaching 267, but certainly never reaching 270.